everyone. Myself Saranya, working as an assistant professor in the Department of ECE at Sri Shanmuga College of Engineering and Technology. Today I am going to discuss about the power amplifiers. So in general, the power amplifier is nothing but it is a electronic devices and it is used to mainly increase the power level of the input signal based on the input signal we are applying at the input side, and it takes a small low power output signal, low power input signal from your microphone, radio receiver and then audio source, etc., and it delivers a high power output signal capable of driving loads such as loudspeakers, antenna and other devices, etc. And the main feature of the power amplifier is it produces a high power output, high power gain, and efficiency, impedance matching, and then linearity is based on the depending on the input and output of the class B and class A type of amplifiers, and it improves the stability of the power amplifier circuit, and then we can utilize the power amplifier in wide frequency response. So in wide frequency response, it covers audio and radio frequency, etc. So the power amplifier, it is based depending on the input and output level of the amplifier circuit. It is classified into 5 types. So this is the basic function. So at input signal, we are applying only a small signal as an input. Either it may be a voltage or it may be a current. An amplification process, it increases the amplitude by using a external DC supply, and output is at the output side, we are getting high output power level at the power amplifier circuit. And the applications, we can utilize the applications for the such as audio systems, radio transmitters, and then television transmitters, motor control system, wireless communication system, and also in medical applications we can utilize the power amplifier circuits. And based on the input and output signal, it is classified into 5 types. First one, class A amplifier, class B power amplifier, class C amplifier, class AB, and then class D amplifier. So in this slides, I'm going to discuss the all types of power amplifiers. So first, I will move to class A power amplifier. So figure 1, it represents the equivalent circuit of the class A power amplifier. So in general, for all the power amplifiers, we are using the BJT type of transistor. So it has 3 terminal, base terminal, collector terminal, and then emitter terminal. So we are applying input signal only at the base of the transistor stage, and we are taking the output at the collector terminal of the transistor stage. And based on the requirements, we need to connect the resistor in the emitter terminal, or otherwise if not needed, we are going to ground the emitter terminal. So this is the equivalent circuit. So RL is nothing but load resistance, and R1 R2 it acts as a potential divider. So the main function of the class A power amplifier is it produces the full entire output signal at the output side. So here we are applying full sinusoidal signal as an input. So in the output of the class A amplifier is same as the input. So at the output signal we are getting the same full input signal. So it covers the entire 360-degree cycle, that is conduction angle. So that's why here I mentioned here the output current flows for the entire full cycle based on the input signal. So it covers 360-degree full cycle. So next one, waveform representation of the class A power amplifier. So this is the waveform representation. So in general, in BJT CE configuration characteristics, we have 3 Q points. So Q point is always located in the active region. So the line drawn between IC and VCE is denoted as AC load line. So based on the conditions, we are plotting the AC load line. So Q is nothing but operating point or quotient point. So we are placing the Q point only at the active region. So then only the biasing will be the biasing conduction will take place in the proper region. So there are 3 regions: active region, cutoff region, and saturation region. So we are applying biasing for the amplifier circuit. So in order to operate the transistor in active region, we need to apply some biasing to the power amplifier circuit. So the transistor remains in the active region for the entire full cycle. The output characteristics with operating point Q1 Q1 and Q2 is shown in the figure representation. So here the ICQ and VCQ represent no signal collector current and voltage between collector and emitter respectively. So when the signal is applied to the Q point is moved to Q1 and Q2. So at the time the output current IC. So IC is nothing but output current because we are taking output only in the collector terminal. So the output current increases to the IC maximum and decreases to the IC minimum. So this is the waveform representation at the input signal. And next, similarly, in same way, we are calculating the output waveform at the VCE terminal. So because emitter, we are going to taking output at the collector and emitter terminal. So voltage is represented as VCE. So similarly, the collector to emitter voltage increases to VCE maximum and decreases to VCE minimum. So this is our output waveform and this is our input waveform. So IC is nothing but collector current. So we are getting same full entire cycle for the class A power amplifier. And next one, there are some few expressions for calculating the power values and efficiency in the class A power amplifier. So first, the expression, we know that IB is nothing but base current, Q is nothing but operating point. So in terms of Q point, here we are representing the current values and then power values and also efficiency. So first IBQ is equal to VCC minus 0.7 divided by RB. So IC is equal to, we know that IC is equal to beta into IB and VCE equal to VCC minus ICQ into RL. So power dissipation, so that is power, AC power is nothing but V maximum minus V minimum into I maximum minus I minimum divided by A. So DC power is equal to VCC into IC and efficiency is calculated by using this formula, that is ratio of AC power to the DC power into 100, and the power dissipation of the class A amplifier is denoted as PD, which is equal to DC power minus AC power. So here I represented some few advantages and disadvantages of the class A amplifier. So the main advantages of the class A amplifier is the current flows for the entire full cycle, that is 360-degree angle. This is the main advantages, and it can amplify only in the small signals. The output is same as an input. So in class A amplifier there is no distortion takes place at the output signal. So this is the main, that is distortion is very less at the output voltage side. And then next disadvantages is it produces very low efficiency, that is 25 percentage, and it provides a low power output. And also the output impedance is very large at the output side in the class A power amplifier circuit. And next one, transformer coupled class A amplifier. This is the type of class A power amplifier. So for improving the efficiency, in previous slide, I mentioned the efficiency of the class A amplifier is very less, that is 25 percentage. So in order to increase the power, in order to increase the efficiency of the class A amplifier, here we are using transformer at the collector terminal. So that is why here the type is mentioned as transformer coupled class A power amplifier. In the same circuit diagram, what I mentioned in figure 1, in figure 1, here at the collector terminal, we are connecting the transformer additionally in the collector terminal, mainly for increasing the efficiency and then power level of the class A power amplifier. So the construction is here in the circuit here, R1 and R2, it acts as a potential divider. Here the resistance, it provides the stabilization of the power level is stable, and the CE is nothing but bypass capacitor. So what is the main function of CE means? It is used to prevent the AC voltage. So that's why we are connecting bypass capacitor in the emitter terminal. So here the transformer used type, here we are representing the type of the transformer is nothing but step down transformer. So the high impedance primary of the transformer is connected to the high impedance collector circuit. So the low impedance secondary is connected to the load. So generally we are connecting the output to the loudspeaker, and then we are using the step down transformer. So the transformer used in the collector circuit is mainly for impedance matching level and to increase the efficiency. So here the RL is load connected in the secondary of the transformer. So the number of turns in the primary is denoted as N1 and the number of turns in the secondary is denoted as N2, and let V1 and V2 denotes the primary and secondary voltage, and similarly I1 and I2 will be the primary and secondary currents present in the transformer circuit. Next one, if the peak voltage, so the circuit operation is if the peak value of the collector current is present due to the signal is equal to 0 at the collector current. So therefore, the maximum AC power is obtained. So in order to achieve the complete amplification process, we need to maintain the operating point at the center of the load line. So in previous slide itself, I discussed the waveform representation. So the same waveform representation is for the transformer coupled class A power type. So the operating point is obviously varies when the signal is applied. So the collector voltage varies based on the opposite phase of the collector current. So based on the collector current, the signal, the output level will be get varied. So therefore, the variation of the collector voltage appears across the primary of the transformer. So this is the function of the transformer coupled class A power amplifier. And for calculating the power equations and then efficiency, this is the formula for the calculation of power values. And when compared to class A type, in transformer, by utilizing the transformer coupled class A amplifier, the efficiency of the class A is slightly increased, so that is 50 percentage. And then advantages of the amplifier, transformer coupled amplifier is here it delivers the maximum power transfer of the at the output signal, and there is no loss of signal at the collector terminal, and excellent it provides excellent input impedance matching of the class A amplifier circuit, and gain is also very high, and DC isolation is provided in the class A amplifier circuit, that is in transformer coupled type. The disadvantages is uh, low frequency signals are less amplified comparatively, and frequency response is slightly poor, and the transformers are bulky and then costly due to the presentation of the transformer in the amplifier circuit. And the applications of the class A amplifier, we can utilize the applications of the class A amplifier in the main criteria for the audio systems, and the circuit is where the impedance matching is the main criteria. So these are the used as the drive amplifiers and sometimes as the output amplifiers. So when the collector current flows only during the positive half cycle of the input signal, so we can utilize the amplifier in radio frequency ranges based on the frequency level of the amplifier circuit. And next type, class B amplifier. So in class B amplifier, the function of the class B amplifier is here the output power is obtained only for the one half of the input signal. So this is the input signal we are applying entire sinusoidal waveform. So the output is obtained only for one half of the input signal. So this is the main function of the class B power amplifier. The same we are using BJT type of transistor, and the collector terminal is connected to the supply voltage. In emitter we are connecting resistance Re, and we are taking output in the emitter terminal, which is denoted as V0, and then V in is nothing but supply voltage. So here the biasing of the transistor in class B operation is such a way at the zero signal condition there will be no collector current takes place in the circuit. So when Vin equal to 0, at the time IC is also equal to 0. So the operating point is selected at the collector level. It is mainly in the cutoff voltage, so that when the signal is applied only at the positive half cycle at the amplified output in the class B amplifier. So due to this condition, in class B amplifier we are getting output only in the positive half cycle, that is in half cycle. So this is the main function. So the conduction angle takes place only for the 180 degree. So this is the function of the class B amplifier. And next, waveform representation. This is the waveform representation of the class B amplifier. So when the signal is applied, the circuit is in act as in forward biased condition. So at that time, it produces the positive half cycle of the input, and hence the collector current flows in the circuit. And during the negative half cycle of the input, the circuit it goes to the reverse bias condition, and there is no collector current takes place in the class B amplifier. So during the reverse bias condition, IC equal to 0. So that's why in class B amplifier there is no negative cycle. It generates only positive half cycle because the conduction takes place in the forward bias condition. So during forward bias condition, IC will be present in the class B amplifier circuit. So hence the positive half cycle is amplified at the output of the class B amplifier. And then negative cycle is considered as zero due to the reverse bias condition. So advantages of the class B amplifier. Here the impedance with the load is possible. We can measure the impedance level of the class B amplifier, and it provides high efficiency compared to class A amplifier. And the main drawback is here in class B amplifier, crossover distortion takes place in the output signal. So efficiency is not so high. So when compared to class AB type, efficiency is very low in class B. But compared to a class B amplifier, efficiency is high. So class B amplifier is classified into two types. One is class B push-pull amplifier and class B complementary symmetry amplifier. So first one, class B push-pull amplifier. So here we are utilizing two transistor stages, that is Q1 and Q2, and the input terminal is connected to the transformer, that is denoted as driver transformer, and output transformer is connected at the collector terminal, and emitter is grounded. So in class B amplifier, the output current flows in the only one less than half cycle for the full input signal. So we are applying full input signal. The output is present only for the positive half cycle. So in this push-pull amplifier circuit, it consists of two identical transistors denoted as Q1 and Q2, whose bases are connected to the input of the transformer, and the collector terminal is connected to the another transformer, that is output transformer. The circuit arrangement of the class B push-pull amplifier is same as the class A. Here additionally we are using another transformer at the input terminal. The circuit of the class B amplifier is shown in figure 6. So when no signal is applied at the input, the transistor Q1 and Q2 act in cutoff state, that is it goes to cutoff state, and hence there is no current takes place, that is IC is equal to 0. There is no current flows in the circuit. So as no current is drawn from VCC and there is no power wastage in the class B push-pull amplifier circuit. So when we are applying input signal to the input transformer, so always we are applying input only in the base of the transistor. So the signal is splitted into two signals. So it is denoted as IB1 and next one IB2. So first we are applying full sinusoidal signal. It getting split into two signal, divided into two signal, and that are represented as an 180-degree out of phase with each other. So these two signals give to the two identical transistor Q1 and Q2. So for the positive half cycle, the base of the transistor Q1 becomes positive and the collector current flows. At the same time, the transistor Q2 has a negative half cycle. So here it is denoted as negative half cycle, which throws the transistor, that is at the time the Q2 act in cutoff condition, and hence there is no current takes place in the Q2 transistor, that is IC is equal to 0. Here we can measure the IC value in Q1 transistor. So the waveform is given in the next slide for the class B push-pull amplifier, and by using these expressions we are calculating the power values and then efficiency of the class B amplifier. So the efficiency of the class B push-pull amplifier is around 78.5%. And the advantages and disadvantages of the class B amplifier is efficiency is much higher than the class A amplifier, and we are using two transistor stages, so hence the circuit is bulky and cost efficiency, and it produces a very poor frequency response. This is the main drawback of the class B push-pull amplifier. And next one, class B complementary symmetry amplifier. So in class B complementary symmetry, we are using two transistor stages. It is denoted as Q1 and Q2. So there is no transformer takes place in the class B complementary symmetry. Transformer is not utilized in the this type of class B power amplifier. So here only one transistor is in half state. So at that time the Q2 goes to half condition, and when Q1 is equal to on state, so we are getting positive half cycle. At the time Q2 is equal to half state, And next, if go to Q1 is on state, so at the time we are getting again positive half cycle, and at the time Q1 is goes to half state. So this is the main function of the complementary symmetry amplifier. And next one, class comparison of the push-pull and complementary symmetry. So the comparison is the main type of transformer we are using. In push-pull is both NPN or PNP type, and complementary symmetry we are using one type as an NPN and another type as PNP type. And use of transformer in push-pull amplifier circuit, we are connecting two transformers, that is in input side and as well as in output side. And complementary symmetry type, there is no need of transformer, just we are using only the transistor stages Q1 and Q2. And the conduction angle for both the type we are using 180 degree, that is the output present only for positive half cycle, and the power dissipation is zero, and efficiency is low in push pull amplifier and high in complementary symmetry when compared to push pull amplifier. Next one, class C power amplifier. So in class C amplifier, so to avoid the crossover distortion in the class B amplifier, we go for class C amplifier. So here we are utilizing only one transistor stages. It is denoted as Q1. And next we are using RB, that is base resistor. It is nothing but biasing resistor. So at the base terminal we are connecting biasing resistance. So in class C amplifier, the output of the signal will generate only less than half cycle of the entire full cycle. That is it around 80 degree to 120-degree conduction angle. So this reduction conduction angle increases the efficiency. So mainly for increasing the efficiency, we are checking the output of the class C power amplifier. And advantages of the class C amplifier is it is less physical size, and it is used in the applications of RF applications, and it provides low power loss in the power transistor. So the disadvantages of the power amplifier is it is not suitable for audio applications, and it creates a interference, RF interference at the output level. And then class AB amplifier. So in class AB amplifier, we are using two transistor stages Q1 and Q2, and we are not utilizing the transformer. So instead of transformer, here we are connector D1 and D2. D1 and D2 is nothing but diode. So for both the transistor at base terminal, we are using diode. It is denoted as D1 and D2. It acts as a pre-biasing circuit. So the main function of the class AB amplifier is, so here we are using active elements, that is transistor are slightly biased, so that the conduction angle is slightly more than 180 degree but much less than 360 degree. So slightly more than 180 degree but much less than 360 degree. So the transistor conduction for more than half cycle but much than less than the full cycle. So that means there will be no instant where both the transistors are half simultaneously, and thus the crossover distortion is eliminated. So due to the pre-biasing circuit, the crossover elimination is avoided in the class AB amplifier. So automatically the efficiency of the class AB amplifier is very high, slightly higher than the class B amplifier. So since the active devices are slightly pre-biased, so there will be a small amount of collector current flowing in the amplifier circuit, and due to this reason behind, the slightly it reduces the efficiency. So in typical, the efficiency of well-designed class AB power amplifier is around 70%. So the output characteristics of the class B amplifier is shown in the next slide. And from the above figure, from the equivalent circuit, so the operating point is takes place only in the cutoff region. So the amount of negative going half cycle reproduced at the output depends on the complementary symmetry of the class AB amplifier. So in pre-biasing, so why we are applying pre-biasing means the transistor using the network mainly for comprising of resistors R1 and R2, and also the biasing diodes D1 and D2. An NPN transistor will start conducting when its bias voltage is above the base emitter voltage. So that is VBE is approximately equal to 0.7 volt. And the PNP transistor will start a conducting when its bias voltage is below the emitter voltage, that is VBE approximately equal to 0.7. So during the forward biased condition, a voltage will drop approximately in 0.7 volt across the pre-biasing circuit. So one important thing is while choosing the biasing diodes, there is a characteristics and it is possible to compensating the diode values based on the VBE value. And next one, the resistor R1 and R2 are actually used for the forward biasing the diodes so that the voltage drop is 0.7 volt across the pre-biasing elements. So C1, C2, it acts as a coupling capacitor, that is input DC coupling capacitor. It allows only the DC signal, and input and output waveform of the class AB amplifier is given here. So we are applying full input signal as an input signal in the power amplifier. So the output signal is at the output signal, the crossover distortion is avoided in the class AB power amplifier circuit. So the advantages of the class AB amplifier is there is no crossover distortion and there is no need for the coupling of transformers. We are using only the pre-biasing stages, that is D1, D2 and then Q1 and Q2 as the main elements of the class A amplifier. And the disadvantages is efficiency is slightly less when compared to the class B configuration. Comparison of the power amplifier. So this is the comparison. So first the current conduction, that is IC, takes place in 360 degree for class A amplifier. So here nature of the output current is represented as in waveform. So that is it covers full cycle 360 degree. And in class B, 180 degree, one half of the cycle takes place in the output side. And in class D, it is less than 180 degree. And class AB, 180 degree to 360 degree. And the efficiency of the class A is up to 50 percentage, and class B we are getting 78.5 percentage. And when compared to class B, in class C we are achieving 80 percentage and above. And in class AB it is higher than A but less than B, that is approximately 50 percentage to 78.5 percentage in class AB amplifier. So distortion, so there is no distortion in class A amplifier, and compared to class A, class B, there is a slight distortion takes place in the output level. So to avoid the crossover distortion, we go for class C, and here also we are getting highest distortion. In class AB power amplifier, just we are avoiding the crossover distortion takes place in the B amplifier type. So slightly we are getting distortion in the class AB amplifier. Next, power dissipation is very high in class A amplifier and low in class B, and in class C also very low, and in class AB the power dissipation is moderate. And Q point position, location of the Q point is in class A amplifier center of the load line. In class B it takes place on the axis, and in class C Q point takes place in below the x-axis, and in class AB above x-axis but below the center of the load line. So this is the comparison of the power amplifiers. Thank you.